Welcome to the Rich Report, a podcast with news and information on the world of big data. Today my guests are from ScaleOut Software. We have Bill Bain, he's CEO, and Dave Brinker, the COO of the company. So gentlemen, welcome to the show today.
Well, thank you very much. This is Bill, and I'm going to start talking, and then I'll be joined by Dave Brinker in just a few minutes. We're very excited to talk to you today about enabling real-time analytics using Hadoop MapReduce. We've introduced new technology with our ScaleOut hServer v2 product on October 1st of this year, and we're very excited to tell you about some of the breakthroughs that this technology represents. So I'm going to start with slide 2 of our deck, and on slide 2 we're going to talk about what we call the world's first Hadoop MapReduce engine that's been integrated with a scalable in-memory data grid. What that means is that instead of running Hadoop MapReduce programs using a standard open source distribution such as Apache, now you can run Hadoop MapReduce programs directly on the engine we've integrated into our in-memory data grid. And that means it can read in live, fast-changing, memory-based data from the grid, analyze that on the fly, and provide answers and results in seconds instead of minutes or even hours for standard Hadoop. So this is dramatically speeding up the execution of Hadoop MapReduce, enabling it to be applied in applications that use live operational data in live systems such as e-commerce systems or financial services applications. Now, we've done measurements with this new engine and measured about a 20 times improvement in performance over standard Apache MapReduce on the word count benchmark. This represents a huge jump in performance over the standard distribution, and we expect it's going to unlock new applications for this technology. Also, it's a much simpler environment to deploy and to use to develop code on the standard Hadoop distribution. And that's because the installation is very quick. It's because it's integrated with our in-memory data grid. It's designed to automatically self-aggregate multiple servers together. It allows a developer to write a simple Java MapReduce program and have it up and running in under an hour without the need to do any tuning of that application or to fuss with the infrastructure connecting the servers. So let's just talk a little bit in slide 3 about our company, ScaleOut Software. We've been around for 10 years now. We were founded in 2003. We've been in the market since 2005. We run on both Windows and Linux. We have about 400 or more customers now running on 9,000 servers. Our goal has been for the full 10 years to scale the performance of applications and then to perform real-time analytics as we scale application performance by taking full advantage of scalable computing techniques and in-memory data storage. My background is in parallel computing, going back to Bell Labs and Microsoft. Dave Brinker has been a CEO of several venture-funded companies, has extensive business and sales and marketing experience. So together, we have built ScaleOut Software to bring this technology to the market. If you look on slide 4, this just recaps some of our products. Our flagship product is called ScaleOut State Server. It's an in-memory data grid for storing data in memory instead of on disk or in a database. And it allows applications to run on a cluster of servers to scale their performance by making that data more quickly available since it's stored in memory and also shareable across the full cluster without the application having to write code to make it shareable. So it simplifies, scales applications across a cluster of servers. It's been used in e-commerce applications on web farms and several other areas, including high-performance computing. Now, we added to that ScaleOut GeoServer, which allows applications to access grids at multiple sites. And then we rolled in real-time analytics with a product we call ScaleOut Analytics Server. ScaleOut Analytics Server has an underlying data parallel execution engine, which we call Parallel Method Invocation, or PMI. And PMI allows applications to automatically perform real-time analytics on data that's scattered across a grid of servers. We ship the code out to the grid servers, perform the analytics, and then return the results back. Now, it's this PMI engine that's the basis by which we were able to build ScaleOut hServer v2 so that Hadoop MapReduce could now run 20 times faster than it does in the standard open source distribution. So we're taking advantage of technology that we have been developing over the last 3 to 4 years to integrate data parallel computation with an in-memory data grid and to then host Hadoop MapReduce on top of that parallel. All right, so let's go to slide 5. We're talking about applications that perform real-time analytics on live data. And that's really where this technology is a different scenario than what you would find with typical Hadoop MapReduce applications. Using in-memory data grids, we can store data that's changing very rapidly within operational systems. So, for example, you might be holding market data that's flowing through a financial services system. And within the grid, you can hold business rules that enable an application to look at the market data and make good trading decisions. Also, you might have an e-commerce system where orders are flowing in and inventory changes are flowing in, and you can reconcile orders and inventory in real time to tune the ordering process and make sure that orders can be fulfilled in the time that the customer requests. So these are examples of managing live data and using real-time analytics to perform live operations on this data and allow business operations to be more competitive. So we can use an in-memory data grid to do this, and now that we have Hadoop MapReduce running, we can structure the real-time analytics in Hadoop itself as opposed to structuring it in lower-level APIs such as the ones offered by ScaleOut Analytics Server. So this is a real boost for the Hadoop developer to now be able to apply that skill set in the area of real-time analytics and deliver results in milliseconds to seconds instead of in minutes to hours. So going to slide 6, we'll just drill down on one quick example of how one can use real-time analytics in a live system. So in the in-memory data grid, we're storing what are called hedging strategies for a hedge fund. This is a real example. We're working with hedge funds in New York, and this is an example from one fund. It's holding the strategies in different market sectors, for example, high-tech, automotive, real estate. And so as the market feed flows in and updates the positions held by each strategy, we can analyze each strategy's business rules to see whether or not the strategy's position should be adjusted to maintain the correct hedging position for that strategy. So we can apply data parallel computation to do this, and by using data parallel computation, the price snapshots can be applied in parallel to all hedging strategies, which can then be analyzed in parallel to deliver alerts to the traders within a second, 1 second or less. Now, in traditional database-oriented implementations of this, it's taking the hedge fund about 15 minutes to review all of the strategies based on the current market prices and then generate a set of alerts for the traders. By being able to do this analysis within 1 second, it dramatically speeds up the hedge fund's ability to react to quick market changes. And one could see how this could be applied in algorithmic trading so that you could automatically place trades as the market changes in the trading day. So this is just one example of how real-time analytics can be applied to live systems to deliver business results very, very quickly. So let me turn it over to Dave to tell you about our customer base at ScaleOut Software and the market we see for real-time analytics. Dave?
Thank you, Bill. So let's move on then to slide 7. And as Bill mentioned at the outset, we have about 400 unique customers, and they're spread across most of the major geographical markets in the world. More than half our customers have multiple deployments, and in fact, some of our larger customers are running us on as many as 10 or 15 different server farms and using us across dozens of different applications in their businesses. As you can see from the pie chart here, we have customers in a wide variety of industries. Financial services and e-commerce have been especially important verticals for ScaleOut, and those verticals have had a strong need for performance scaling to meet heavy workloads. And we've had a lot of success in those markets. And we expect that that's where we will see, and in fact we are seeing, a lot of interest in analytics as well. The table to the right gives you a sense of the breadth of use cases where our customers are using our products. We can add value to just about any application where scalable performance and fast analytics are needed. Moving to slide number 8. Let's talk about the market for a minute. Over the past several years, in-memory data grids have become an important segment in the major computing markets that you can see in these 3 circles. So from a business point of view, that uptake in IMDGs is being driven by the need to meet competitive pressures. And it's also then being enabled from a technology point of view from things like larger servers, faster networks, cheaper memory, and of course, software like ours. In the HPC and enterprise software markets, those 2 bottom circles, the need to scale application performance has been the primary driver for adoption of in-memory data grids. Where we're currently seeing strong interest in our products is in the big data analytics market, that blue circle. And in that market, in-memory data grids provide the means to do real-time analysis on live operational data, as Bill has mentioned. So we think that's a key area for IMDG adoption over the coming years. Moving to slide 9, we've just drilled down a little bit on that blue segment of the analytics market. And you can be broken into two subsegments. And on this slide, we're showing these as batch processing and real time. And the batch market is characterized by what you might think of as traditional business intelligence. So in other words, mining huge data sets that are stored on disk typically, with the goal being to discover trends that inform business optimization decisions. The real-time market is really just emerging. And some people are referring to this as operational intelligence. And it's characterized by analyzing live data sets to discover and capture immediate business opportunities. Or alternatively, to discover issues that might need to be immediately addressed in your business. So our focus at ScaleOut is on the real-time segment. And we have two products for that market, ScaleOut Analytics Server and ScaleOut hServer, which Bill has talked about both of those in an introductory sense, and we'll talk more about them. And specifically what we're talking about today is the second release of ScaleOut hServer. And as Bill mentioned, that it uses the underlying analytics server technology to be able to run Hadoop MapReduce code on data held in the memory data grid or streamed in fact, from another data source. So the exciting thing about ScaleOut hServer v2 is that it opens up these real-time use cases for Hadoop use. Moving to slide 10, these are the three areas that we see as being prime targets, if you will, for the use of ScaleOut hServer in a real-time sense or in other fast computation use cases. So the first one is to run continuous Hadoop on live operational data, and that maps directly to the example that Bill gave with the hedge fund. You would also think about that as being useful in maybe real-time shopping recommendation, reservation systems, risk analysis, etc. The second one is the idea of running Hadoop code on static data. So this is not a real-time case, but the advantage here of having everything in memory and executing very quickly is the ability to do very fast what-ifing. And that can be applied to use cases like developing models in manufacturing, back testing in financial services, drug simulation, etc. So again, it's the idea that in this case the data isn't, but you want to do very fast iteration against a static data set. Then the bottom one is kind of interesting. It's sort of a subset of the middle one. We hear from Hadoop developers that developing Hadoop code is really time-consuming, mainly because of two things. First, you have to install and manage the Hadoop stack of software. And second, the turnaround time to run your Hadoop program and debug is very long. So hServer helps in both of these regards. It's not necessary to be running the full Hadoop stack of software, so that's eliminated. And then the ability to execute code and maybe a subset of your full data set in memory allows you to do very, very fast debugging. So those are really the three areas that we're targeted on. So with that, let me turn it back to Bill to dig into the product a little. Bill?
Well, thank you, Dave. So let's look at slide 11, and let's see what are the limitations with the standard Hadoop distribution that really inhibit its ability to perform real-time analytics. Well, first of all, Hadoop has always from the outset been designed for large, static, typically offline data sets hosted on disk. So one of the overheads comes from moving data from disk into memory. When you have large static data sets in the petabyte range, you would typically want to store those in a disk farm, maybe in a NoSQL file system or a database, or HDFS is the primary data repository for Hadoop. So you're moving data from disk into memory, and that creates overhead. Now, we addressed those overheads with ScaleOut hServer v1, which was in last April, by creating mechanisms for both caching HDFS data and also for serving data directly from the in-memory data grid into the standard Hadoop MapReduce. Now, the second set of overheads that we see with Hadoop have to do with the lengthy batch scheduling overhead and also the shuffling overheads and sorting overheads that are inherent to the MapReduce execution process. Now, with ScaleOut hServer v2, we're addressing those overheads by providing an integrated, standalone MapReduce execution. And by having the combination of technologies from v1 and v2 together, we can really drive the performance of Hadoop MapReduce to support real-time analytics. So if you go to the next slide, slide 12, you can see how the integration of an in-memory data grid with a Hadoop MapReduce engine can really drive performance. First of all, by staging data in memory, whether it originates from HDFS or originates from live data in the grid, we now can serve it up to MapReduce much more quickly because we're tightly integrated, and we can move data very efficiently between the grid and the MapReduce engine itself. Also, we can rethink and re-implement the batch scheduling and data shuffling mechanisms to drive down those overheads to milliseconds instead of tens of seconds, and thereby dramatically speed up the execution of a MapReduce application and drive that latency down to second and sub-second. Also, having the grid as the repository of data and as the repository for the results means that we can analyze live data on the fly as it's changing, so we can allow updates to the data. Unlike HDFS, any data object, any key value pair that's being analyzed by MapReduce can simultaneously be updated by the grid itself, the grid APIs. So we're allowing Hadoop MapReduce applications to take advantage of the efficiency of this integration and deliver real-time performance. And they can run without change. You don't need to modify a Hadoop MapReduce application to run in the grid. The one change that's required is to redirect the job object to point to our subclass of the job object. That's a one-line change. Once that's done, the rest of the application, the map code, the reduce code, the input and output formats, and record are all running without change. In fact, it's the standard code that the customer would with Apache MapReduce. So this is dramatically going to simplify the development process and allow customers to very quickly run their application and get results by using hServer v2. So let's just look at slide 13 for a minute, which gives you a recap of what's available in ScaleOut hServer v2. It's, as I said, it's an integrated and standalone MapReduce engine, and it has various options for accessing data. I want to point out that data can be served from live data held within the grid, and with v2 we're introducing new data storage layout and access mechanisms within the grid that are new to our product and new to in-memory data grids to handle very large populations of fine-grained key-value pairs, as you would typically find with Hadoop MapReduce. So now you can host sensor data, individual market prices, very small key-value pairs that would not be efficient to ordinarily store within an in-memory data grid, which typically is designed to hold much larger objects. So we can not only host very fine-grained objects, but we can efficiently get them into the Hadoop MapReduce. You also can just stream data directly from HDFS into the MapReduce engine. So the only limitation on the data set size is the size of the intermediate data between the mappers and the reducers, which we hold within the grid. Other than that, you could stream in petabytes of data as long as the intermediate, the output of the mappers, is small enough to be held in the grid. And in-memory data grids today can hold upwards of a terabyte or more by just scaling out the number of servers within the grid and automatically combining the memory available in each server together to form a very large memory-based storage repository. So that's what's in hServer v2. We have some details that I think we probably don't have time to go into, but just touching on slide 14, you can see that we've built mechanisms to very efficiently move data from the grid into the MapReduce. And if you look at slide 15 briefly, you can see that there are mechanisms for not only serving data into MapReduce from HDFS, but also transparently caching that data within the grid and reserving it in the subsequent run of that application from the grid instead of from HDFS. both of these usage models for serving data to the grid are available with ScaleOut hServer. So let me turn it over to Dave to tell you about how we're selling the software, how we're distributing it, and then I'll get back and I'll wrap up and tell you what we've learned today. Dave?
Okay, thanks, Bill. Moving to slide 16 then, ScaleOut has historically been in a market where the players in the market have been commercial software vendors offering proprietary software. With the ScaleOut hServer, we're now talking a lot more with the open source community. So we've decided to offer hServer in a community edition. And this community edition is free. It can be used on data sets up to 256 gigabytes on up to 4 servers. And there's no restriction on its use as to production or evaluation. It can be used in either way. So we think a common use of the community edition may be for rapidly developing your Hadoop code, as I mentioned earlier. And this community edition is supported via a community forum, which we're also hosting on our site. In terms of commercial editions, they are priced on a per core basis, and they'll support very large configuration. And of course, will come with our full scale-out support, just as our other products do. So that's a very brief snapshot of how we're coming to market with this product. Turn it back to Bill to wrap it up.
Okay, thank you, Dave. So what we've learned today is that in-memory data grids, this technology for storing data in memory on a cluster of servers, helps applications to both scale their performance and to examine live real-time data as it's changing within an operational. And in-memory data grids have been increasingly deployed in these environments, operational environments, over the last decade to enable applications to deliver the fastest possible performance and to make the most efficient use of their stored data. So what we're introducing with ScaleOut hServer v2 is the ability to analyze this data in real time using standard Hadoop MapReduce technology. So now a standard Hadoop MapReduce application can be executed directly within the confines of an in-memory data grid to analyze data in real time and deliver much faster results than would be possible by moving this data offline to HDFS and serving it to one of the open source distributions of Hadoop. And as I mentioned, we're seeing 20 times improvement in performance on the word count benchmark, and this will vary on an application-to-application basis. But I think in pretty much every case where the data set can be analyzed by ScaleOut hServer v2, we should see a dramatic performance improvement over the standard distribution. And that's because of the numerous techniques that have been implemented within this product to stream data as efficiently as possible into the mappers, from the mappers to the reducers, and then back out to result storage, whether that be the grid or HDFS itself. So this will enable Hadoop to finally be applied to live operational scenarios and not just be in the back office analyzing static offline data. And it's providing flexible methods for accessing data from both in-memory and file-based sources. And as Dave mentioned, it's really a very fine environment for doing development of Hadoop applications, because in many cases, especially when the data is being served from the grid and the results stored in the grid, the Hadoop tuning parameters such as splits, slots, and partitions are automatically set by ScaleOut hServer. So this simplifies program development, enables the application developer to focus on the application and not worry about tuning the Hadoop execution environment. So this not only simplifies development and speeds performance, but allows rapid prototyping of applications. So altogether, I think we've introduced a game-changing environment for running Hadoop MapReduce applications, and we're very excited to move this new technology into the operational scenarios that our company has traditionally focused on over the years. So thank you very much, and what questions could we answer for you?
Well, thanks for that, Bill and Dave. Well, the first thing that comes to mind, walk me through this. I mean, if we installed, say I have an existing Hadoop setup, right? It's a bunch of servers with local disk, and I want to do your hServer with an in-memory grid. Do you wheel in a new set of servers and use that Hadoop, set up my current one as a data source, or how would it work?
Okay, that's a great question. So If you have an existing Hadoop infrastructure, you would typically install ScaleOut hServer v2 on the same cluster of servers that the task tracker nodes are running within your Hadoop infrastructure. And that means that for every node in the grid, a node in your cluster in which you're running HDFS, you would also have an in-memory data grid node able to run hServer v2. And so what that means is if you were to run your Hadoop application within a ScaleOut hServer v2, it can move data from HDFS into the grid very, very efficiently because it's co-located on the same nodes as HDFS itself. But we do not require any installation of Hadoop MapReduce or any of the Hadoop distribution within on the cluster of servers on which you run our product. So I'm talking about a situation in which you already installed Hadoop, but if you're, say, running in an operational scenario where you just simply have an in-memory data grid, or you don't have an in-memory data grid, you have a cluster of servers, say a web farm, you can just install ScaleOut hServer v2 without ever installing Hadoop itself and be able to run MapReduce analyses of your data.
Right, right. So how big are we talking? How big can the in-memory portion of this be with your software?
Well, the only limitation is on the size of the intermediate data, the output of the mappers, which typically is much smaller than the size of the input data set. So, for example, if you look at word count, you may examine a petabyte of lines of text, but the output really is a measure of the number of independent words you are going to see and the count of those words. So the intermediate data output from the mappers in word count is very small relative to the input data set. So for applications which have that property, you could analyze petabytes of data with hServer v2 because the data simply streams into the mappers, is filtered by the mappers, and the output of the mappers is being stored in our grid is very, very small, maybe in the hundreds of gigabytes. We typically, within a grid, store hundreds of gigabytes to a terabyte. As technology advances, and as the use of solid-state disks becomes feasible over the next couple of years, we expect grids to be able to hold petabytes of data. But today, it's reasonable to say it can hold terabytes of data. And so the intermediate data set should fit into an in-memory store that can hold, of that size, approximately a terabyte or less. But the original input data set, as I mentioned, can be extremely large, as can the result data set, because both of those can be streamed back from HDFS and to HDFS on the output side.
Well, great, but what seems to me to be really exciting about this is this near real-time capability, especially for financial markets where your footprint is a little smaller at this point than some of the other things. But do you see this as a great growth path for your company? Wall Street people that want to be able to, do almost real-time trading and have that capability?
Yes, we would not say that you would use this technology in algorithmic trading, which seeks to make trading decisions in under 1 millisecond. We're talking about a time domain in the range of several hundred milliseconds to a few seconds. So typically, that would be used in Wall Street for risk analysis, feeding to live traders, to human traders making the actual trades. But the ability to apply Hadoop, which has proliferated very rapidly across the Java community. So there are numerous people with the skill set to write data parallel analyses and to very effectively mine data sets results. To bring those skill sets to bear on this application domain in financial services, e-commerce, other applications, credit card fraud detection, logistics, is a huge breakthrough from our point of view because now the skill sets can be applied where the real-time problems exist.
Right, right. So in the credit card example, right, I mean, this is fast enough to, you only got a few seconds to either approve a transaction or not, right? So,
right.
I mean, that as a market, do you have any feel for how big that might be?
Dave, maybe you have some numbers on that. We know that it's an important problem, and and we know that it's fast growing, and also that this is a perfect technology for it. The size of the market opportunity for credit card fraud detection, I don't have that number.
Yeah.
Dave, can you add anything to this?
Well, I don't have that number, but we do have a customer already in that market that is very interested in expanding the use of our product. They've been using us for several years, but the exciting thing about that market is it's very different than just watching transactions go by and saying, based on this historical profile, we should approve or not approve this transaction. You're actually able to analyze maybe the history of that particular user in real time and make a much more informed decision on what action to take on the proposed credit card use.
Sure. So well, kind of a wrap-up question here, guys, with your community edition. How easy is it to kick the tires on this and see if it's right for my business?
Dave?
Well, this is extremely easy. So you can go to our site, ScaleOutSoftware.com, and just click on the hServer link that's under products. You can download the community edition, totally free. And by the way, there's no registration required. We're not asking for names or emails or anything like that. There's also a programmer's guide that is on that same page that you can download. And with those two things, and there's in that programmer's guide, there's also the word count example code. So it's very easy for someone to download it and get started with it. And of course, we're always available by email or in the forum to support your evaluation.
And let me add to that when you download a ScaleOut hServer or any of the ScaleOut products, installation typically on one server is under one half an hour. So the first time it might take you half an hour to sort it out, but after that, typically our customers install on a new server within about. It's simply a matter of unpacking an RPM, assign Windows, and then the product self-aggregates, so it self-deploys, makes it very simple.
Well, terrific. Well, Bill Bain and Dave Brinker, I want to thank you both for coming on the show today.
And thank you very much. We really appreciate the opportunity.
Yes, thank you, Rich. We enjoyed it.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on the world of big data.